Hello guys, today we are gonna derive Schrodinger's wave equation, which is actually time independent Schrodinger's wave equation. For that, let's take a wave function as psi. The psi represents here the wave function. This does not tell us about the wave, but this is actually a representation of a wave. Let's take it as psi equal to cos of kx minus omega t plus I sine of kx minus omega t. This is a general representation of a wave like we do usually as x equal to a sine omega t, which is the equation of SHM where x represents displacement, a represents amplitude. Similarly, this is the equation of the wave through which we can derive dx by dt, that means velocity of the wave or acceleration of the wave. Similarly, this is the representation of the wave where we have represented it by psi, which we call actually as wave function. This generally is the function of the wave in terms of cos and sine. Now let us use de Moivre's theorem over here. De Moivre's theorem. According to de Moivre's theorem, cos theta plus I sine theta equals e raised I theta. This is known as de Moivre's theorem, which all of you might be aware about. So let me use the de Moivre's theorem over here. That means this cos of kx minus omega t plus I times, sorry, this is not a bracket over here, sine of kx minus omega t equals e remains same, I remains same, but for theta we have kx minus omega t. Using the value over here, we may write psi equal to e raised I kx minus omega t. Now let me differentiate this psi with respect to x. There are actually two variables in the equation, x and t, but as I already told you that I'm gonna derive the time independent Schrodinger's wave equation. That means the equation should be independent of time. dt is not allowed over here because that would mean that the equation the time is a variable over here, but I'm going to derive the time independent Schrodinger's wave equation. That means I have to take into account x. Now I will differentiate this psi with respect to x. It comes out to be the differentiation of e raised power x is called again e raised power x, but when when the power is individually differentiated, it comes out to be I into k multiplying with this e raised power x. Again, let me differentiate this d2 psi by dx square equals e raised power I into kx minus omega t into I square k square. From the basics of complex numbers, I know I is equal to root of -1. Therefore, I square is equal to -1. Also, I know k is equal to 2 pi by lambda. This is a basic formula in physics. Now, I also know that lambda is equal to h divided by p. This is known as de Broglie's wave equation. Wave equation. There's another formula in physics that says h Planck's constant equals 2 pi h bar. Now rearranging this, I get h divided by h bar is equal to 2 pi. Using these values 2 pi over here and lambda, 2 pi and lambda in k, I get k equal to, for 2 pi I will write h by h bar, and for lambda I have to write h by p. 2 pi equal to h by h bar, so I will write k equal to, for 2 pi I will write h by h bar, and for lambda equal to h by p. That means I will write h divided by p for lambda, which comes out to be this, and this will cancel out. P will come into numerator divided by h bar. But I'm interested in I square, that is this minus 1, and I'm interested in I square, which is called minus 1, and k square, which is over here equal to k square, comes out to be p square divided by h bar square. Now substituting these values of I square and k square in, let me call it as first, in equation first, I get d square psi by dx square equal to e raised to I kx minus omega t, as it will remain same. For I square I will write minus 1, and for k square I will write p square by h bar square, p square by h bar square. Now transfer this minus and h bar square over here, I will get minus h bar square d square psi by dx square equal to, I know, e raised to I kx minus omega t. E raised to I kx minus omega t is equal to psi over here. Therefore I will write psi into p square, psi into p square. Let me call this one as equation second. Now again, from the basics of physics, I know total energy is equal to kinetic energy plus potential energy in a mechanical system. Total energy equals kinetic energy plus potential energy. That means total energy equal, from the basic formula of kinetic energy, 1 by 2 mv square plus, let me represent potential energy as capital V. Don't confuse this V with this V. This is the velocity of the particle, which is having the kinetic energy equal to this, and this is the potential energy of the same particle and the mechanical energy Te. Now I also know that linear momentum of a body is equal to mv. Let me turn the page, sorry. I also know that P equal to mv. Therefore V equal to P by m. Using the value of P, V square equal to P by m over here, I will get total energy is equal to 1 by 2 m v square. For v square I will write P by m whole square plus total plus potential energy. Total energy equals 1 by 2, 1 m will go with this 1 m, p square by m plus v. Now multiplying this total energy by psi, which is the wave function that I already discussed. Psi, let me call this total energy as E, equals 1 by 2 as such. psi into p square by m plus psi v. This v over here, I again say, is potential energy, not the velocity or something else, volume. It's just potential energy. If you remember, I already derived psi into p square over here. Psi into p square equals minus h bar square d square psi by dx square. So using the value of equation second in, let me call this as third, using value of second in third yields psi e is equal to 1 by 2 m as such. Psi into p square, for that I will write minus h bar square dou square psi by dou x square dou square psi by dou x square, and yeah, that's it. And the other thing that remains is plus psi v. Therefore psi e equals minus h bar square by twice m dou square psi by dou x square plus psi v. This is what we call as time independent Schrodinger's wave equation. This is time independent wave equation. Here you will find nowhere there's nowhere the time in it, but you can find x over here that we already differentiated on that point when I told that we can't differentiate it like this dt. That's why this is known as time independent Schrodinger's wave equation. Thanks for watching.